Okay, hello my dear students. As we already started with the module 4, it is that is design of a three-phase induction motor, it is there. So in that module only the very important derivation from exam point of view. So this is the design of a rotor bars and end ring current here. So in which part we are studying now? On the rotor part it is there. So the based on the rotor construction, the induction motors are of two types it is there. The which are those? One, it is the squirrel cage induction rotor, and one more it is the slip ring, or it is also going to be called it as a wound rotor induction motor. Getting my point? The first thing we'll concentrate on the squirrel cage induction rotor here. So in that only the designing of this rotor bars as well as the end rings what we are going to study now. Okay, let me start with the session. See here, before proceeding to the derivation, let we have a glance about the squirrel cage induction motor here. So this squirrel cage induction motor, basically it will be consist of a rotor bars it is there. So these rotor bars are going to be short circuited. These rotor bars are going to be short circuited. How it is short circuited? By connecting them to the end rings here. So this end ring as well as the rotor bars, which are made up of a material, that is conducting material, aluminum or the copper will be there, and it is provided with the steel laminations. Laminations, what purpose we have provided means in order to reduce the eddy current losses. Getting my point? So as we are already familiar with the basic construction as well as the working of the induction motor it is there. So how it is going to be works? See here, when we give a supply to the stator winding, when we provide a supply to the stator winding, that is three-phase AC supply, then what will happen? Due to this alternating supply, a rotating magnetic field it is going to be gets produced. Due to this rotating magnetic field, what will happen? The flux it is going to be starts flowing in the stator here. So due to this stator flux, what will happen? The EMF it due to the change according to the Faraday's laws of electromagnetic induction, whenever there is a change in the flux, then only EMF it is going to be gets induced in the circuit itself. Then what will happen? Due to this rotating magnetic field, there will be a inducing of the EMF. Due to this induced EMF, the flux it is going to be produced inside. So whatever the flux, that it is going to be called it as a stator flux. Though this stator flux, it will travels through the air gap and then it cuts the rotor it is there. Is it right? So in the rotor bars also, so what will happen? The flux it is going to be produced due to the due to the EMF induced in the rotor it is. So getting my point, which will be whatever the EMF it is going to be gets induced in this rotor bars, which will be sinusoidal over the one pole pitch it is. So what is pole pitch? The pole pitch it is nothing but the angular distance between the sides of a coil, nothing but the sides of the bars here. So or else it will also be the angular distance between the centers of two adjacent poles here. As the rotor will be completely short circuited body. The short circuited in the sense that it will be a closed path will be there. So due to the EMF induced, the current it is going to be starts to flow through the rotor it is. Getting my point? So whatever the current it is going to be flowing through the rotor, where it will flow? So that current should be get distributed in the rotor bars as well as in the end rings here. But that is only very complicated process. The distribution of the current as well as the distribution of current in what? Rotor bars and end rings of a squirrel cage motor. It is very complicated. So why it is complicated? Let me see. So the first thing it is the distribution of the current in the rotor bars, that is represented by IB. I in the sense that current, B stands for the rotor bar it is. Then whatever the distribution of the current, if it is there in the end rings, means that will be represented by IE it is. I in the sense that current which is gets distributed in the end rings, that purpose small e is nothing but the end ring it is. Getting my point? So that only will start the derivation. Okay. So this one, sorry, see here. So this is the derivation of this one. The first thing it is what I said here, the distribution of this current in the rotor as well as the end rings of a squirrel cage motor, it is very complicated process I said here. So see here, the stator winding, there are in an induction motor there are two types of there are two types of winding it is there. One, it is the stator part, one more it will be rotor part it is there. When we give a supply to this rotor winding, that is of a 3-phase AC supply, so this winding which is of a distributed winding it is. So what is the use of this distributed winding type? So distributed winding means what? The conductors are going to be placed under several slots and the conductors will be equal in number. Keep it in mind. So the stator winding, it is provided with the 3-phase alternating supply, and this winding is of which kind? Distributed type. So what is the use of this distributed type windings? The distributed type means what? The conductors are going to be placed under several slots and these number of conductors will be equal in number, and that is the reason this kind of a winding which usually reduces the armature reaction and also helps in the better cooling. That is the reason this the stator winding which is of a distributed type it is. Getting my point? So when we give 3-phase alternating supply, when we give means due to this alternating supply there is a production of the or the development of the rotating magnetic field, nothing but the RMF or the revolving field it is going to be produces. Due to this rotating magnetic field, the EMF it is going to be gets induced in the rotor part it is. The whatever the EMF it is going to be gets induced, that is in the fundamental frequency in the rotor bars here. See here, and that is only shown in the figure A here. So this figure A, it is nothing but what? There is I had considered here, consider the first in the figure A, consider a group of rotor bars. So these are the rotor bars, and this rotor bar it is going to be completely short circuited with the help of what? Both the sides end rings are connected here. Getting my point? See the diagram carefully. So in one set of, this is the one half and this will be the another half here. So in one half the rotor bars send a current to the end ring in one direction, that is upward direction it is there, and in another half the rotor bars the current will send to the end ring in the downward direction it is there. The first half will send the current to the end ring in one direction, and in second half and in another half the current which is sending to the end ring will be in a opposite direction it is there. So getting my point? The EMF induced in the, that is only I had considered the EMF of a fundamental frequency in the rotor bars which is shown in a figure A it is there. So next thing it is in figure B, what it is there? So whatever the magnitude of EMF that is produced at a fundamental frequency, where the EMF it is going to be induces in the rotor bars only. So in the rotor bars, whatever the EMF it is going to be gets induced, that will be in the nature of sinusoidal in nature. So this figure B indicates what? The magnitude of EMF of a fundamental frequency in rotor bars. And in figure C, then figure C you can observe it here. So the EMF whatever it is going to be produced in the rotor bars, due to this EMF induced, there is a that will results into a circulation of the current. What it is there? Whenever according to the Faraday's laws of electromagnetic induction, whenever the change in the flux, the EMF it is going to be gets induced. Due to this EMF, what will happen? There will be a circulation of the current will be there. So this figure, see what it indicates? The EMF, whatever the EMF it is going to be gets induced in the rotor bars would circulate the current, as it is also in a sinusoidal manner it is there. Just you check it here. So this current flowing will also be in a sinusoidal manner it is. So getting my point? In the rotor bars as well as the end ring current, the EMF induced in the rotor bars would circulate the current here. This is the circulation of the current. Next in figure D, what it indicates? So this is nothing but the wave which is representing the how the current which is flowing in the end ring. So this is the current which is flowing in the end ring, and this will be the wave for the current which is flowing in the bars here. So this diagram, I hope it is clear to you. So okay, let me start with derivation. So first thing it is, for that purpose we'll consider the considering a group of rotor bars. Group of rotor bars I had considered under one pole pitch. So pole pitch means what I told here, that is the distance between the angular distance between the centers of a coils here. Okay. under one pole pitch, the group of rotor bars I had considered. So one half would send a current to the end ring in one direction, and in another half it will send the current to the end ring in the other direction. It is getting my point. Suppose if the maximum value of this current, in each bar, so that how will represent? That is IB max here. Just you see here. So that is nothing but the current it is going to be represented. B stands for the bar, that is I, and this will be the maximum current here. Suppose if the maximum value of the current in the each bar, that is represented by what? IB max here. Okay, let me next we'll go to next slide. See here, we'll make it zoom. So if the current, so what I told here, the current, maximum amount of the current which is flowing in the rotor bars, that is represented by a IB max here. Suppose if the current is maximum in all bars at the same time, the first case what I am considering here. So if the current is maximum in all the bars at the same time, if the current is maximum in all the rotor bars, then how we'll take this one? Then the maximum value of the current in the end ring. So current in the end ring how will represent? So this will be represented by the IE max, nothing but the maximum value of the current in the end ring, because the current which is flowing through the rotor bars, it will give the sum of all the currents which will go to the end ring itself. So that is the reason the maximum value of the current in the end ring, it will be represented by IE max here. I had not written here, but it is represented by IE max here. How we'll take this one? So see here, how many bars are there per pole? So in one pole pitch I had considered, is it right? Per pole, how many bars are there? Divided by 2. Why I had done? There will be 2 poles. One it is south pole and one more it will be north pole. Bars per pole. In one pole, how many bars are there? Divided by 2, because there are 2 poles will be there. One it is south and one more it will be north. And into the current per bar. In particular bar, how much amount of the current which is flowing. So how will represent? The bars per pole, it is represented by a SR divided by 2 here into what I had taken here, current per bar. In the bar, B stands for the bar, current I had taken, this will be the maximum value of the current. So this is the first equation. What is the first equation? IE max is equal to SR divided by 2 into IB max it is. Call this equation as a 1 it is. Suppose, so this is the case when the current it is maximum in all the bars at the same time. Keep it in mind. So however, but the current it is not maximum in all the bars under one pole at the same time. The current will not be same. Current will not be maximum in the bars under one pole at the same time, but it is going to be varies. Why it is going to be varies? Because it is in a sinusoidal manner. Sometimes it will be minimum, sometimes it will be maximum in nature. So that is the reason at the same time the current will not be maximum under one pole in case of a rotor bars. So but that current it is going to be varies according to the sine law here. So in that case we'll take the maximum value again here. So suppose it is varying in nature, minimum, maximum, it will be there in nature. So under that case, we'll take the maximum value of the end ring current. So this maximum value of the end ring current will be represented by what here? IE max it is there. So this will be given by equal to what it is there? 2 divided by pi into SR divided by 2P into IB max it is there. So this one it is nothing but the 2 divided by pi, it is nothing but the average value we have to take here. The minimum value, maximum value. So in a particular one bar, so this will be varying in nature. That is the reason sum of all the currents, whether it is a maximum or a minimum, at the same time current will not be maximum in the rotor bars. That is the reason I had taken the average value, whether it is a minimum, maximum. The average value in the sense that 2 divided by pi I had taken here. So into this is the what is the current which is flowing in the end ring here from the first equation. So that will be written as a SR divided by 2P into IB max it is there. So call this equation as 2 here. So next thing it is, but what I told here, but the bar current it is going to be very sinusoidally. So that is the reason how it is going to be sinusoidally, in the sense that the IB max will be equal to root 2 times of the IB here. So now IE max, how we'll write down now? So this one 2 divided by pi. So this IE max only I had taken here into the average value of this one. So 2 divided by pi into SR divided by 2P into IB max it is there. IB max means what is there? Root 2 IB. That only I had substituted here. Root 2 into IB it is there. So next thing it is, when we take the RMS value of the entering current. RMS value means the maximum value of the current divided by root 2 it is there. So IE will be equal to IE max divided by root 2. IE max means what we got here. So that will be 2 divided by pi into SR divided by 2P into root 2 IB divided by what? Root 2 I had done here. 1 divided by root 2 into IE max it is there. So this one only I had substituted here. From this equation we can write it now. So IE is equal to 2 divided by SR I had written as it is. This root 2 will get cancelled. Then now, and the upper part what is remaining in the numerator? SR into IB it is there. Then divided by this 2P it is there. This 2 will get cancelled. What is remaining in the denominator? Pi into P. So this will give the amount of the current which is flowing in the end ring it is. So this is the derivation for what? Designing of the rotor bars and end ring current it is. I hope it is clear to all of you. Okay, thank you.